Hello everyone. Our today's class will be on matter waves. Yes, the name suggests the matter is that it is the waves associated with a matter. It is a very new concept to all of you and very important also. This is one of the fundamental concepts behind quantum physics. It was suggested by Louis de Broglie. Louis de Broglie suggested, and his idea or this theory is known as wave-particle duality, though it is more precisely thought as a hypothesis. Means it doesn't have a direct proof, but its calculations and results the things we observe. Now, in the previous chapter of photoelectric effect, we have seen that Einstein used the Planck's concept to say that for each and every energy that is carried away, we used to thought them as waves. But Einstein suggested that the energy travels like particles, and those particles he called them as photons. So it's very clear that for each and every wave we can get a particle. For each and every wave we can get its particle nature. Just like for the light wave, we get the corresponding particles which are called photons. So we have for each and every energy waves its particle nature. Now, Louis de Broglie suggested that nature loves symmetry. Means we all know that if A equals to B, then of course correspondingly B is always equals to A. Yeah, that's a very normal example I'm giving that is not connected with the theory actually, but just need to understand that if waves have particles nature, then it is a huge possibility that each and every particle is also having wave nature. Particles having wave nature means just this pen. This pen is a solid block and it is having made up of huge number of particles, so a wave can be associated with it. Let's see what de Broglie suggested. De Broglie suggested that the Planck's idea says that each and every particle is actually, each and every wave has a corresponding energy of E equals to h nu, where nu is the frequency of the wave and h is called Planck's constant. Its value is 6.6 into 10 to the power minus 34. Now, similarly, Einstein's formula suggested that energy can also be calculated in terms of mass and velocity square, where m is the mass and c is the velocity of light. So de Broglie suggested that if energy can be thought in terms of waves and particles both, why can't we equate them? Means he equated E equals to mc square, that is equals to h nu. So we can see from this equation what we can arrive is something very different. mc square equals to h nu. Means the left side of the equation is a completely particles portion and the right side of the equation is a wave concept. Let's see how. The m is a mass and mass is only connected to particles. Waves we do not consider or calculate their mass, and c is the velocity of light, whereas nu is the frequency, and that is a completely concept for waves, not for particles. So it is also very different from the particles concept, but we have equating the one side of the equation is with mass and the right side is frequency. Means the particle nature is equated with the wave nature, and this is the beauty of de Broglie's hypothesis, where actually we can relate the particles with waves. Let's see the formulas of calculations here. Louis de Broglie showed that the energy E equals to h nu, so mc square equals to h nu. So from here we can calculate its mass formula. Also these things can be calculated in terms of wavelengths. Why only frequencies? Now we know E equals to hc by lambda, and again E equals to also mc square. So we can write mc square equals to hc by lambda. So I can cancel c from one side and mc equals to h by lambda. Clear? So this is the calculation of mass equations in terms of wavelength. Now let's see what further we can calculate. We can calculate the mass directly in terms of waves. Let's see how. Say mass mc square was equals to E, that is equals to h nu. So m can be considered as h nu divided by c square. Now the momentum, which is the mass into velocity, that is m into c. Now if we can put the mass value h nu by c square, we arrive h nu by c square into velocity c. So momentum can also be calculated as h nu by c. So we have seen the momentum of a particle is now calculated in terms of frequency. So this is the wave nature of the particle. Similarly, it can also be calculated in terms of wavelength. If we focus here, E equals to mc square and E equals to also hc by lambda. So we can equate that mc square equals to hc by lambda. Now cancelling c from both sides, we can reach from here mc equals to h by lambda. So m equals to h by c lambda. So this is the equation of mass in terms of wavelength. So it's a very typical concept. We are calculating mass in terms of some wavelength. That is the equivalence between the particle nature and the wave nature. More things like momentum. Momentum is again mass into velocity. So h by c lambda, which is the mass, can be multiplied by the velocity c, and finally we reach the equation of momentum in terms of wavelength, that is p equals to h by lambda. So far we have calculated many things where we have calculated mass, momentum of the particles in terms of their wavelengths. Now the question might appear to your mind that why, if this each and every particle has some corresponding wavelengths, means corresponding wave, means if each and every particle, like from this pen, if wave is coming out, from you, from me, if a wave is coming out, why can't we see those waves? Let's find out what is the problem in the concept, or is there any problem with our measurements, means with our observational ability. Let's find out.